Okay, today we are talking about chapter 6, which is hypothesis test with means of samples. And what we did up to now was about in the population that the mean and standard deviation of the population was known. We wanted to observe what's the probability of observing a value that we have observed or greater, or what's the probability of observing this observed value that we have got this score or less. Now, what we could do, we get the z-score and then look up in the normal tables and find the probability of observing a z-score of that or greater, or observing a z-score of that or less than. And it was just where we were talking about the population of the individual scores. But in real life, we never do take a sample of size 1. We take a sample of size n. And for example, if we want to test whether people will do better on a test that they are given instructions to answer each question with the first response it comes to their mind. All right, so that's the hypothesis. We say people do better if they give answer for the first thing it comes to their mind. Now, what the researchers do, they take a sample of size 64 from 5th graders, school children, and they give the test in the usual way they given the test, except that they add the instruction as a statement that children are to answer each question with the first response that comes to their mind. Now, from previous testing, the researchers know the population mean and standard deviation of the test when it is given the usual way. All right? So, in these situations, instead of a single score, here we have got a sample mean. All right? So, now, as sample means are variables, and each of them provide an incomplete picture of the population, now we have to use the distribution of sample means here. And the rules between samples and populations should be discussed. Here, when we do all the steps of hypothesis testing, everything is the same for when we have a sample of size n instead of size 1, only the comparison distribution is different. So the objectives for this week are to understand the distribution of means as a comparison distribution, to conduct hypothesis testing with the distribution of means, to identify the characteristic of the distribution of means, and to figure the variance and standard deviation of distribution of means. And we explain why the variance of the distribution of means is less than the variance of the population. And then explain why the larger the sample size, the smaller the variance of the distribution of means. These are all very important concepts. Then we figure the p-value and we talk about confidence intervals. Now, let's have a look at an example. So, by now, the only thing we're talking about is, instead of talking about the population of individuals, we talk about the population of the sample means. So, as we said, we take a sample of size n and we talk about this x bar. And then remember that we can have, instead of, these are x1, let's say. This is x2, okay? But now, what we are talking about, it is, imagine the same population, but then we have got x bar 1, x bar 2, x bar 3. So imagine if we have got thousands of x bars, we are talking about the distribution of means. Now, the example we want to talk about is, suppose we wish to test the effectiveness of a new stress reduction method, and it is known that in the general population, the mean score on the test of stress level is 40 with a standard deviation of 10. Now, a randomly selected person is trained in the stress reduction method, and a test to determine stress level is administered with the observed score being 25. In here, we have got X is normally distributed, and the mean is equal to 40, and standard deviation is equal to 10. 25. So let's, in the next video, I show you how we approach it if instead of just a score of one person, which is 25, we have got a mean of 25. Thank you.